Hello everyone, hope all of you are doing well. In today's session we're going to learn about three most important relations that is included in your relation and function chapter, that is your chapter 1 of your class 12 math syllabus, that is reflexive relation, symmetric relation and transitive relation. We're also going to learn that if a particular relation satisfies all these three conditions, then that particular relation is known as equivalence relation. Now first of all, for those of you who are new in this particular channel, let me tell you that I have already discussed the empty relation and the universal relation, which are, by the way, both known as trivial relations, and also the identity relations. The link of all those videos you will find in the description, so do go ahead and watch those videos as well. Now without any further delay, let's get started. Now first of all, let us understand what do you mean by reflexive relation. For that we need to have a Cartesian product of a set with itself. So let's make the Cartesian product, and those of you watching this video, let me revise it for you once again. Say suppose we have a set A, and in this case I have taken two elements, that is 1 and 2. all right, so let's make the set a little bit smaller so that you can understand it in a better way. Now we know that when we perform the Cartesian product of the set with itself, what happens is that ordered pairs are formed. Now the first question that a lot of students ask me is that how many ordered pairs will be formed. Now that will depend on the number of elements that is contained in A. Suppose the elements is 2, and obviously you are performing the Cartesian product of the set with itself, so just multiply the number of elements with itself, you will get 4. So clearly we will have 4 ordered pairs. Now in this case it will be 1, 1, 1, 2, 2, 1 and 2, 2. all right, now how do you get this ordered pairs? Let us quickly again revise it. How do you map it? First of all, the first element of set A will be mapped with 1, and then it will be mapped with 2. all right, similarly the element 2 will be having a mapping with 1, and it will be having a mapping with 2. all right, so that is how the ordered pairs are formed. Now having known that, let us try to understand that what do you mean by reflexive relation. Now if you read the definition, in a reflexive relation every element maps to itself. For example, as we have taken in this case, the set contains 1, 2. The ordered pairs that will be received after having the Cartesian product will be 1, 1, 1, 2, 2, 1 and 2, 2. Having said that, you have to understand that we have the set as 1, 2. Now this particular relation R will be reflexive only and only if it contains the ordered pairs 1, 1 and 2, 2 both, because here it is said that both the elements should be having a similar element in the ordered pair. That means that both the elements should be mapped with the similar elements, but nothing has been said about if you have some additional ordered pairs as well. Right, so if we have this particular ordered pair like 2, 1 or 2, 2 as well, then also this particular relation will be known as reflexive relation. So this is the definition of reflexive relation, and this is how we denote it in a mathematical manner. Now having understood what is reflexive relation, let us now move on to symmetric relation. Now symmetric relation is very interesting. Why? Because the word symmetric in itself gives us the clue what do you mean by a symmetric relation. Now first of all, we have to understand that the definition states that if A equal to B is true, then B equal to A is also true. In other words, a relation R is symmetric if B comma A, that is the ordered pair, belongs to R when A comma B also belongs to R. That implies that, let me give you a very small example here. From the same example, of course, if we see a relation, suppose we have 1, 2 in this particular relation. Now this particular relation will be called symmetric. When it will be called symmetric, understand this particular relation will be called symmetric if 2, 1 is also there in this particular relation. Alright, so if this is the situation, then this particular relation will be known as symmetric, and this is how we denote it in a mathematical manner in relations and functions. Also do remember that it does not matter that if you have some additional ordered pairs here, as long as this satisfies this condition, we are good to go. Like say suppose we have a particular ordered pair 1, 1. Now if it stays, it's not a problem because the reverse of it is also true. That means 1, 1, if we just have the symmetric ordered pair here, 1, 1 will be 1, 1, so this will still be a symmetric relation. So let's move on to the last type of relation, that is the transitive relation. Now transitive relation is actually again very important, because for a transitive relation to happen, this particular definition has to stand out, and for that reason we have to understand this with a different example, because this example is not equally qualified to make you understand what is transitive relation. Now for instance, if you have a set that contains 3 elements, that is 1, 2, 3, and you perform the Cartesian product of the set with itself, then we already know that what are the ordered pairs we are going to get, right? I've already shown you the mapping, so I'm not going to repeat it. I'm directly going to write the ordered pairs, and the number of ordered pairs that you're going to receive will be 9. All right. So here in this particular Cartesian product, we'll have the ordered pairs like 1, 1, 1, 2, okay, 1, 3, and similarly 2, 1, 2, 2, and 2, 3, and also the ordered pairs having the first element as 3, 1, then 3, 2, and 3, 3. Now in this particular Cartesian product, we have to see a particular thing, that say suppose we have a relation R which has a ordered pair, say suppose 1, 2 and 2, 3. Now when this particular relation will be called as transitive. Now this particular relation will be called transitive if 1, 3 is also there in this particular relation, because you see what is happening here is that this 1 you treat it as x, and this 2 you treat it as y, and this will be your y and z. So if x, y belongs to R and y, z belongs to R, then x, z should also belong to R. So that is the definition of transitive relation. And if all these 3 conditions are being followed by any relation, that is the relation is both reflexive, symmetric and transitive at the same point of time, then this particular relation will be known as equivalence relation. As you can see that if a relation is reflexive, symmetric and transitive at the same time, it is known as equivalence relation. So this is the video, guys. I hope you have clearly understood what do you mean by reflexive, symmetric and transitive. In case if I've missed anything, do feel free to comment in the comment section. I'll definitely try to address it in the next session. Also do find yourself free to check out the remaining videos which are pinned in the description. In the future we'll be coming up with lot more videos and the past year solved question papers as well. Till we meet next time, God bless you and thank you all.